Morning. Good morning. Welcome to the third and final part of the quantitative research methodology sessions. Up to this point, you have been introduced to some basic principles around quantitative research, and that is what the first session offered to you. And then after that, I also had a session where we looked at different experimental designs. We looked at some quasi-experimental designs, and then we gave a lot of attention to non-experimental designs, things like correlational research, causal comparative research, and that sort of thing. Then along with that, I exposed you, or I gave you an in-depth overview of the survey research methodology as a means of data collection, and introduced you to different survey options. And really, it was a way of kind of orientating you to one of the data collection approaches that's often used within quantitative research. I identified strengths and weaknesses of that approach. I also showed you different hybrids, as in things like computer-assisted surveys and so forth. All of that was part of the first and second parts of this series of sessions on how to select a methodology, and all those were really focusing on the quantitative options. But of course, in quantitative research, one of the key things that people need to be acquainted with, and it'll be a central element of your study too, is this the whole issue of sampling, and actually the processes that you go through to identify the specific population that you will be focusing on. So given that, I've set up a specific session that focuses specifically on issues to do with sampling. But before I get into that session, I just want to go through some administrative things. As you know, we begin the session with a visual presentation of this nature. Then I will take myself off screen and upload the presentation that you should be focusing on. And this is predominantly what we're going to have in front of you here. And then this session will then be what I will beam through for you. We will be sending all the PDFs or PowerPoint versions of these presentations for you to get to grips with. The particular set of presentations that focus on quantitative research designs are all presented as one very, very long presentation, but for the purposes of delivering it to you, I've separated it out into 3 bits. The first bit basically went through concepts that are foundational concepts that you should know. The second part went through the experimental designs, quasi-experimental designs, and also non-experimental designs. And then it also looked at survey as a method of data collections. And then finally, the last part, which is what you will have now for the next 40 minutes or so, looks at the whole process of sampling and setting up a sampling strategy for your study. So I will quickly page through to that section and trust that this is what you will be seeing. Right. Okay, so remember part 2 that you have is this focus on the sampling plan, issues to do with populations, data collection, and data analysis. And of course, I will share with you some critical perspectives. And as always, I think you all know me by now. You know that the beginning of any conceptual interrogation always starts with us defining the basic concepts that are central to what it is that we're looking at. And then, of course, I will follow that with some targeted examples of, in this case, it will be targeted examples of quantitative sampling. Remember, these sessions so far have been focused only on quantitative options. So the qualitative set of sessions will follow after this. But then I'll introduce you to those, and then I will also share some critical perspectives around that. So to begin with, I will write. So as always, we begin with just a definitional overview of what it is that we're looking at. We're focusing on sampling, and Pollitt and Beck, who are very well-known research writers, particularly in the health field, they see sampling and define it as a process of selecting a portion of the population to represent the entire population so that inferences about that population can be made. So key standout things here are that it's a process, and it is a process of selecting only a proportion. And when I say a proportion, I mean that when you sample in the truest sense, sampling means that you are getting a representative proportion of the bigger population or the bigger source of subjects that you're taking your sample from. And then you use that proportion to draw inferences about that very sample that you that very population from which you drew out the sample. So the specificity of this is that firstly, it is a mathematical process. It is a process that is based on probability, and what I will then reveal to you are the ways in which that probability is assured, the steps that are taken or the methods that are used to ensure that there is a mathematical probability-based representation. In the world of sampling, there are some specific terms that are used, and it is important that I give a very, very brief insight into these terms, because when you write your proposal, or indeed when you write your thesis or dissertation, the expectation is that you will talk about things using this very specific terming convention. So firstly, when you hear the word or use the word population with respect to quantitative research and with respect to sampling, you're actually referring to the entire sum total aggregate of cases in which the researcher is interested. So basically, in simple English, what we're saying is that a population are the total number of people that, or the total number of cases that are represented in the group that you're interested in. So if, say, I was doing a study on male behavior in specific contexts, say how male students behave in relation to X or Y, then my population would be all male students at the specific institutions that I'm interested in. That is the population. From that population, there's something that we call an accessible or source population. And that really is in some ways kind of self-explanatory, but I will clarify it for you. It refers to those members of your big population that meet both your inclusion criteria and are also available and reachable so that they can be study subjects. So I may say to you, I'm carrying out a study on all the males at University X, If there are some males who are registered in that university, but due to resource limitations, due to their remoteness, they are not available, then they become inaccessible. So then you would say, look, your population has 10,000 potential study subjects, but from that, only 6,000 represent the accessible or source population. You're basically saying that you're going to draw or source out your sample from this smaller designated group because they are available and are reachable and are accessible. So you now can tell the difference between this plain use of the word population versus the use of the accessible or source population. Then, of course, within that group of people that are accessible, there are then the specific group that the researcher is interested in. So you may actually be interested in doing a study of male students at a university, but you are interested in the male students who completed, and therefore your target population becomes that accessible or source population that completed their studies. So your target population are the aggregate of cases about which the researcher intends to generalize. So if I'm going to study those students who did not pass, then of course my findings will allow me to generalize about students who have not passed. And that is what a target population is. And I ask you, these terms that I've referred to, or these differentiations, are very important in quantitative research. They are critical when you write up your proposal. They are critical when you write up your thesis. You need to be very explicit about what the population was and what part of that population were accessible or represented the source population from which you could actually draw out a sample. Then you must specify very clearly who you are targeting or what your target population are. Then, of course, there's this other thing that we call the sampling frame. Now, the sampling frame is identified as the source material or device from which your particular intended sample will be drawn from. So if, say, for example, you were studying students at University X, then the sampling frame would probably be the list of all registered students or the database from which you get this list. So of course you will discover that some things do not have sampling frames. So if I wanted to study people who have attended or who have shopped from a particular grocery chain, I may not know how many people actually came. There's no list that tells us who attended and who didn't. So that particular example may not have a sampling frame. But particular examples where the population is being drawn from a database, from a list, from a register of sorts, then the expectation is that there is a sampling frame. And that register in its completeness represents your sampling frame. And of course, there are cases where your sampling frame may actually be the population also. So someone will say, this is the list of all the people who are registered, and I will draw from this list in its entirety. So that list becomes your population too. There are times where you have a sampling frame that will tell you a list of everybody, but from that it will have certain lists of people who are not available because they've not paid their registration or whatever it is. So then the population that you become interested in differs. So you may find that there are often cases where the sampling frame is the same as the population, or there are cases where the sampling frame and the population are not the same. But the expectation is that when you write your proposal or indeed make reference to these things in your thesis, you are able to say the sampling frame for this study was that, the population was that, the accessible or source population was this, and from that source population, the target population were X. Then it is, and so when people do sampling, there are particular formulae or formulas. Really, when I say formulae, I mean more than one formula. There's a range of these formula that allow us to include certain data, like you can input the population, say how much of that population is accessible, say what your target population is, then you press a button, and the particular tool that you're using or sample size calculator will compute for you what your specified samples ought to be. So that's basically the terms that are important, foundational terms. I will leave this slide on for about 20 seconds just so you can reread the 4 differentiators, because they are critical foundational things that you need to be aware of. Now, another concept that's important within sampling is these concepts of inclusion and exclusion. And some of you may have met this in other spaces, but it is important that we make reference to it here. And really, inclusion and exclusion criteria are those criteria that you use to determine eligibility for members of a particular population to be deemed as appropriate for consideration as the target population. So when we say what are your inclusion criteria, we are asking for the sets of things that you'll be looking out for when you study a particular population, for you to decide that this is the people that I really want to target. And normally, typically, when you do inclusion criteria, you look at things like whether there are characteristics that you're interested in, that you want to include people as a result of. Sometimes there may be things like resource limitations or associated costs that make particular elements of bigger groups difficult to engage. For example, if you were doing a study and you didn't have the ability to translate or do interpretation, you would make an exclusion criteria be that anyone who does not speak English will be excluded. Of course, with every decision that you make, there are implications. People would then ask, what does that mean in terms of your ability or authority with regards to you saying you really studied the full population? But nonetheless, inclusion and exclusion criteria allow you to identify those things that you will look out for and take note of, so you can make decisions that particular types of potential subjects can be included. It also allows you to identify those things that make particular subjects more likely to be excluded. So things like being a non-English speaker, in some cases, people who are unable to attend interview venues are excluded. Maybe people who may be too unwell to actually participate. So sometimes you may do a study that's looking at, the risk of suicide among students, for example, and you might decide that, look, you will only talk to students who are not actively suicidal right now, because you may prompt responses that are outside of your study to deal with, and that will then be an exclusion criteria, and so forth. So, of course, the other thing is some of the restrictions that may exist as exclusion or inclusion criteria are determined by restrictions that go with your design. So you may decide that, look, you are only interested in people who have been exposed in a very specific way. And on that basis, you then decide that you are excluding those people who possess different attributes. Of course, once you apply inclusion and exclusion criteria, you define your population in such a specific way that this will impact on your ability to generalize. And in reality, what if you make your primary target population be people who only speak English, who are this, who are that, then when it comes to how you generalize, you can only generalize to a group of people who are similar to those that you studied. And that is a particular consideration that is a central balancing act when you do this journey of introducing inclusion or exclusion criteria. Hauser and others have tried to put together the general steps that people follow when they are developing what we call a sampling strategy. Now, you will notice that, and I find this, that the order in which they say things happen is not always the same for everybody, and it presents itself in different ways at different times. Right, so the first step, it really is around determining what the target population that you are going to focus on will be. And of course, I've said that to get to the target population, I'm referred to you having to get a sampling frame, and that sampling frame becomes a list of all the people who are in the potential population that you're interested in. And from that, you're able to then determine who is accessible and who is not. And then once you have done that, you then are in a process in the fourth step on this slide that you've got in front of you, then talks about your random selection process, and of course the application of inclusion and exclusion criteria and so forth. And then finally, once you have got people who meet all these discriminating actions that you speak about, you'll be left then with the group that you're interested in. And in the case of experimental work where you have a control block, then you would also go ahead and do random assignment of participants from the control group to the experimental group, or vice versa. Once again, as I've said, the steps 1, 2, 3, and 4 and 5, really the order in which Hauser depicted them and the order in which they happen in real life is not always the same. And there are other textbooks that have represented it differently. But the bottom line with the first 5 steps of this is that it is about cleaning out your targeted population so that you end up with the very people that you are interested in, and also you have applied all the sensitive inclusion and exclusion criteria so that any things that would become feasibility problems are attended to before you can say, I now have a clean population from which I will draw. Now, in the world of sampling, there are 2 specific typologies, 2 types. People speak about non-probability sampling, and then they also speak about probability sampling. In simple terms, non-probability sampling is sampling that is non-mathematical and does not depend on mathematics or aspirations of getting quantitative representation and so forth and so forth. And that type of sampling, and I'm referring to non-probability sampling here, is associated with qualitative research. So when we speak about qualitative research, I will introduce you to non-probability sampling. But in quantitative research, where, as you already know, the focus and the emphasis is on quantitative methodologies, it's on mathematical positivist approaches, where numbers are the order of the day. In that space, in the space of quantitative research, the methods of sampling are all probability-based sampling. And I will introduce you to 4 specific types. There are many others, and what sometimes happens is people, and as this, you will notice that this is a common trend within research, people will take one type of approach and mix it with another, then they'll come up with a word that is a hybrid of the two, and it may not be necessarily well published, but you as you read it, as a reader and a consumer of this, you would be able to discern and identify this because it is a simple combination of words that you individually know. And once they are joined together, you'd be able to get a sense of what the joining of 2 things that you know is likely to mean. But for now, I will speak to 4 specific examples or types of probability sampling. The first is simple random sampling, followed by stratified sampling, cluster sampling, and systematic sampling. Now, in the world of quantitative research, the specific design space that we're talking about, the most foundational type of sampling that there is simple random sampling. It is seen as a basic building block of all probability sampling. So everything that we decide and discuss that is to do with probability sampling, whether it's a more complex type of probability sampling, all of it has the foundational DNA of simple random sampling buried in it somewhere. And of course, with random sampling, the most traditional type of random sampling you would be aware of is this picking things from a hat, much like a raffle type of sampling approach. If, say, you knew you wanted to identify 10 people out of 50, you would put the 50 names in a hat and just randomly select the 10 people. So that is a form of simple random sampling. Of course, mathematically, you would input all the names and then just press a little button on any one of these statistical softwares that we are exposed to, and that will generate for you a simple random sample, a sample that has been generated through simple random sampling. Of course, we know that simple random sampling is entirely mathematical. So we know that because it's mathematical, every one of the potential 50 things that are in a hat have an equal chance of being selected. But even when after they've been selected, there is no guarantee that the attributes of the 10 things that have been selected are a pleasant representation of the big picture. So you may, by chance, happen to pick 10 things that all look the same, but the other 40 remaining things in the hat may be different, but the very fact that mathematically they did not get selected becomes a subject of a function of chance rather than a function of you subjectively saying I will include this, I will not include that. But that's simple random sampling. So it's a very basic form of sampling where you just select what you want through a randomized process. You can do it computer assisted or otherwise. Then, of course, the next step or the next type of sampling that I want to introduce you to is stratified random sampling. Now, stratified random sampling is also a type of random sampling, but the difference is that actually there are things that we call strata or subsets that you, the researcher, are aware of and believe that you want them to be specifically represented. I know that this description is probably a little bit difficult to make sense of. So usually when that happens, the best thing is just to offer a living example. Say, if you were to conduct a process of sampling, so maybe you could study the performance of students. Once again, I try and use a topic that I think will relate to all of you. So right now, you're all students, you're all striving to perform. So my examples will be located along this type of line. If, say, I was studying the factors that influence student success, and I was aware that maybe for me to fully get a good picture of this, I need to have a representation of female students. I need to have representation of male students. I need to have representation of students who are 100% students. I need to have representation from students who work some of the time. So already those four subsets, important strata that I believe exist in the big population that I'm looking at. And if I want them all to be represented in my sample, then I would choose stratified random sampling and make sure that there is some representation of all those and that it's almost designated representation. So if I knew that the university or my source population or the accessible population was made up of 80% men and 20% women, I might decide that, look, I want my sample to also be to have a representation that's similar to what real life is or what the bigger group is. So I then might decide that, okay, when I select my sample, I want that sample to have 80% men and 20% women because I'm drawing it from a population that has that type of proportion. So that ability to create smaller subsets that you randomly select for is called stratified random sampling. Of course, the strata that you choose cannot be a thumbsuck. Remember, I said about research that everything you do is systematic. For that reason, when you generate or identify your potential subsets, it can't be that you just decide, oh, I'll choose this, I'll choose that. You have to have some information from related research that might tell you that, look, if you're studying student success, gender matters. If you're studying student success, the level of someone's poverty matters. If you're studying student success, whether they are career students or whether they are students who are also working, all of those things matter. And if you have research that tells you that, then you can decide that those subsets, the gender subset, the type of student you are subset, whether you're rich or poor subset, you want those subsets to be represented proportionally within your sample. So to do that, then you would create strata when you randomly sample. So you make sure that your random sample is not just made up of men only without women, or students who are career students without identifying those students that work also. So that's what stratified sampling is about. You may want to replay this particular section because I know that people kind of struggle with that a little bit. Now, along with stratified, so stratified sampling, if you remember, was about choosing to have particular types of subsets or particular strata represented within a sample. So in those strata are things that have been shown to be relevant factors before, factor groupings. Cluster sampling is different in that it is basically what people will call multi-stage sampling. And what that means is that you may decide that you are interested in studying university students, and you decide that, okay, you will, in that group of university students, they come from potentially 27 different universities. So the first thing that you do is you will randomly select the universities that you're interested in. Then in those universities, you will randomly select the students who make your big population. And maybe in that big population, you are interested in students who have passed. So you will then randomly select those that have passed. And maybe in the students that have passed, you're interested in those that passed the first time round. So you randomly select from that. So you have multiple layers of random sampling. And that is what cluster sampling is about. Of course, when you do cluster sampling, all you're doing is you've randomly selected units, and you randomly select from those units until you get to the numbers that you want. Of course, there is no there's lower representativeness than in stratified methods, because you don't sit and say, oh, I want to ensure that I protect this proportion, or so forth or so forth. You don't function like that. You just literally are doing multi-stage sampling, and then sampling from the sample, and sampling from the sample, and so forth and so forth and so forth. Now, the next type of sampling that we speak about is what they call systematic random sampling. Now, this type of random sampling is used particularly when people do not have access to understanding what the population that they are looking at is, or they also don't have a sampling frame. So if, say, you were interested in studying people who go to a grocery store, and you didn't know how many people passed, but you wanted to do it over a day, you could go in the morning and say, look, every fourth person that passes me, I'm going to stop them and interview them. Every fourth person. You will carry on and carry on and carry on, but you don't know what the sampling frame is. All you know is that you've got this sampling interval that you're applying. Of course, there are all sorts of questions with this type of method that people have questioned whether it is indeed a true probability-based methodology, but it is used as a method of sampling in any case. And I think it is important that we acknowledge its existence, albeit that it is not typically the best approach to randomized sampling that exists, but there may be practical reasons why that will be so, why it may be the thing that you choose. I will just put that in front of you for a second so you can consider it. Okay, so I've introduced you to 4 basic approaches for random-based sampling. And one of the things with probability-based sampling, or all this use of randomized things, is that if you want to say you have mathematically ensured that there is representation, you must then therefore go for a probability-based methodology. And of course, there is this thing called sampling error, which actually can only be calculated if you do a mathematical calculation. And I will explain to you. And sampling error really relates to you reflecting how much of an error you believe exists in terms of the fact that your sample would have accurately identified the number and subjects that are required for you to claim that it is indeed representative of the bigger group that you're studying. Of course, this randomized sampling approach can be complex, and I've only shared some of the complexities here. And by virtue of it being complex, it is challenged with being seen as sometimes impractical. So as far as sample sizes go, you will see that when it comes to quantitative or qualitative inquiry, which is unlike quantitative inquiry, the qualitative research will say, look, I'm bound by the rules of selecting things by virtue of their number. They talk more about focusing on individuals who meet the criteria that they're interested in, the quality of that particular informant, and of course, that becomes a bigger driving force. But with regards to sample sizes in quantitative research, those are mathematically determined as such, and we will speak a bit more about how you get to that mathematical determination. What I want to show you are some of the factors that people talk about when they do sampling. So when you are sampling, beyond just choosing the people that you want, there are some factors that are critical and need to be taken account of. So the first thing is this thing of how homogeneous the population is. So if you are studying a group of people who are of the same background, they're very, very similar in many, many attributes, and there's 100 of them, you probably need a much smaller number for you to be quite confident that you have understood the population well. But if that group have got different strata in them, some are tall, some are short, and those strata are seen to be relevant, then of course you need a much bigger sample size. So the extent to which the population is homogeneous will affect the ability, or otherwise your ability of being able to decide if the sample size should be small or big. Then there's this issue that talks about effect size. And this actually really is it's a measurement, it's a mathematical measurement that builds on power analysis and expresses the strength of relationship between variables. So you can calculate the effect size of something, and if you are studying, say, the relationship between gender and people's success, if there's a lot of research and existing information that shows that the relationship between gender and success is one that is very strong, then of course the sample size that's required for people to gain the necessary confidence will be smaller. This issue of effect size, we look at it much later on in this program, because it's a slightly more complex thing, and it works best when people are dealing with numbers. So we have a blast session that looks at these things. Then the next bit that affects decisions around sampling is this issue of cooperation and attrition. So when you calculate a sample size, be aware that there are people from that sample size that are unlikely to cooperate. And then there are some people who will drop out or whatever. So if the sample size you calculate says you need 10 people, then some people will say, look, I'm going to add an additional 10% to buffer against attrition, dropout, or people just leaking out of the process in one shape or another. And of course, then what we also know is that if you're going to analyze, if say you are doing a more complex form of sampling than just random sampling and you've got strata sampling, then it means that each of the strata need to have enough numbers on their own for you to carry out adequate analysis when you use the software. So in essence, the type of a stratified sample versus a random sample would be much, much bigger because each strata needs to have enough representation in it for you to be able to carry out the analysis of that specific strata. This slide here, I think, is there just to add to many of the things that I've said so far, but in itself, it is not required. Right, okay. The two slides that I've presented to you are basically saying this, that when you develop your study, you're going to have to have objectives. And each of your objectives that you do, when you analyze them closely, you'll get a sense of whether the objective you have is an objective that's quantitative or qualitative. So in the case of quantitative objectives, you may then have to decide that, okay, so this is the objective. I must now decide what participant group will be useful for me to undertake and satisfy that objective. Then what is the outcome measure that I am interested in, or what is the end point that I'm interested in with this particular subject, a range of subjects who will answer this objective. And once you do that, then it is on that basis where you almost develop sampling approaches that fit each objective, because different objectives are likely to require different target groups who are from different populations and so forth and so forth. And that's basically what these slides that I've got are sort of looking at. Now, I will just jump very quickly to something. Okay, now I want to just look at how people will represent how they've calculated their sample size. So when you eventually write up your sample size, you will see that people have this number that's a CI. Usually it's 95%, and that 95% confidence interval is them actually saying, look, we are 95% sure that these things, our mathematical processes that we have followed in identifying the sample are indeed mathematically sound, and that what we have seen is a product of probability and not a product of just simple chance. I know that's a little bit tricky, but replay what I've said and you will get to that. So really that confidence interval is just an expression of how confident people believe that their randomized process has really given them the representative population that they want. Of course, if you do smaller numbers and your samples are smaller, then your confidence level drops. And if it's below 95%, it's generally viewed as not possessing the veracity for it to be accepted as an academically sound or scholarly sound sample that you've come up with. So it is important that you really, when you do your sample calculations, which I will show you how you do, you make sure that you seek a sample that has that level of confidence. Then, of course, there is another value that you come across, and that value is the margin of error, which is 5%. Normally, what they're saying with the margin of error of 5% is that they are saying that when we calculated this sample of ours, we believe that there's a possibility of up to 5% that we didn't get the representation right. So, but you'll notice that 95% is the confidence that we got it right, and 5% is more or less the confidence that we didn't get it right. So the two of them are literally mirror images of each other. But it's not always that straightforward, although it's something that we need to really think about when we get to the issue of being much more specific in our development of sample size calculations. Now, I mentioned that we have sessions that will look at effect size. They also look at this concept of power. I will also speak much more about confidence intervals, speak to you much more about margin of errors and so forth. But the one thing that I need to show you, and this is more for people who are in the process of developing their proposals or in some shape or form trying to calculate their samples for their studies. You can go into this link that I'm sharing here with you, and I will leave it up for a while. It is, of course, something you can Google. You can just go to Google and put EpiInfo sample size calculator. And one of the calculators that will come up is, in fact, a calculator that allows you to input things like your target population, your population, your sampling frame, what confidence interval you're aiming for. And generally, we aim for a 95% confidence interval. And what margin of error you're aiming for, you aim for a 5% margin of error. You input all those things and you press the button, then it'll give you a number. And that number becomes your sample size. Of course, that number can be increased by you saying, look, the sample size is 386. I'm worried that 10% of the people might drop off. So I'm going to add an additional 10%, 38.6, let's say 40 more people. And that's how you end up with the sample size that you are expected to define for your study. Now, I've included some useful reading around quantitative sampling, and those three things that I've put up there are very, very good reads for you, and I really highly recommend them, and I wish that you will, hope that you will pursue them as expected. And what, of course, then follows this is that once we have identified or introduced you to this world of sampling, you must then go in and kind of look at in greater depth what probability sampling is about. Look at, I showed you 4 different typologies. I've given you some insights into those. You can then try to look at the objectives that you have for your study and make decisions about what objectives are quantitative or qualitative, and what would be the best way to identify my target population. Do I do it through randomized sampling? Do I know enough about the sample to be able to identify strata that exist? And then I need to differentiate my sample so I have a proportional representation of important strata within, or subsets within, my population, and so forth. So all those things become much, much more fluid for you to do once you have this foundational knowledge, but you keep trying it out and reading up on it. The next sessions that we're going to have will present qualitative research designs, and from that we will also talk about sampling within the qualitative world. And then finally, we will bring it all together when we look at mixed methods research. And I hope that you found this useful. Once again, the actual slides for this presentation will be emailed to you. I know a lot of people send me emails after this saying, how will I get my slides? You have to have registered for the program. And if you have registered, then we will email you. Yeah, and that's basically how it works. Thank you very much. I hope you have a great evening. Take care.